I want to show you an interesting example of something you can do with section views. This is a cable-stayed pedestrian bridge that goes over Delta Highway in Eugene. These are the Delta Ponds. Valley River Center is back behind the photo. And the Oregon Department of Transportation has a 1% for the arts policy. So anytime they do construction, they do something artistic. For this pedestrian bridge, they wanted a sculpture at one end of it, and the person who won the commission for this sculpture was MD Imonen, who teaches sculpture at Lane Community College. And he chose to do a sculpture in honor of the Calapooians, the people who used to live in the Willamette Valley before the Euro-Americans arrived. There's a lot to say about them. I will try not to go off on a tangent, but I would love to tell you more about them. Send me an email if you would like to talk about them. Anyway, sculpture over here at the end in honor of the Calapooians. So Lee, the sculptor, decided to do something that looked like fishing nets, like they would put into the river, with poles that would be holding those nets. So here's the sculpture. And here's where section drawings come in. You can see by looking at these poles that they are arranged at all different angles, and they are compound angles, which means not only are they tipped in the X direction, they're tipped in the Y direction at a different angle. What Lee needed to have was a drawing of these base plates because he needed to go to a machine shop and get holes drilled out just the right size to fit each of those tubes, and then a fabricator would weld the tubes into those plates. So getting those angles right was tricky. It happened that at the time he was doing this sculpture, there was a student in the drafting program who also worked with Lee and who volunteered to make drawings for him. And here's what he came up with. He has a separate drawing for each of those base plates. Here's one for a big oval base plate that has 3 holes in it. And so on this sheet he gives the dimensions of that ellipse so that someone could cut the ellipse, and he gives locating dimensions for the small holes around the edge. But then he says go to subsequent pages for the other details. So we'll look at what did he do for this hole. Here is, here is that oval plate. There is a cutting plane line that is at an angle, and he is given that angle at 55 degrees off of horizontal. So that's one of the directions that whole center line is going to tip. And now he says, go look at this section view up here, section AA, where you will see that it is also tipped at 107 degrees off of vertical. And here's the size. So he has given the machinist the angle in this direction, in the horizontal direction, and using a section view, the angle in the vertical direction. When you do not have room to line up a section view with your other view, like an orthographic multi-view, then you put a label next to the cutting plane line. And this is the first section, so he put A on one end, A on the other end, and now this section is labeled AA. Then on the next page, here's a similar situation with section BB, and here is section BB. That hole has completely different angles. This is 101 degrees, that's 98 degrees, and then he has a third sheet with section CC, and it is cut this direction. There's that little hole that he cuts through. Now, he does not use that revolved, rotated convention because this is not a circle, it's an ellipse. And again, section CC is over here with the angles. After Lee sent these drawings to the machine shop, he went to visit the machine shop. Well, actually, the drafter went to visit the machine shop and asked the machinist, how did these drawings work for you? Could you use them? And the machinist said, oh, yes, they were great. I would not change anything. These are just right. I knew exactly what to do. And so he drilled the holes in this 1¼ inch plate, and the fabricator was able to install the tubes. And as you saw in the PowerPoint slide, the sculpture came out beautifully.